Let's have a look, see. So, what they did was they drew a graph of this function here. Everybody cool with that? They put it into their calculator, they drew it. Now, the next thing is, the first thing I'm noticing is, they then broke it up, and they factorized it into this. Now, I'm not happy with that factorization. Can somebody tell me why I wouldn't be happy with that factorization? Look at the 2x plus 6 in the middle. What should I change that to? It should be x minus 1. It should be x minus 3. It should be x minus 4. And the 2 should be on the outside. Everybody cool with that? Now, let me explain the difference here. I'm just going to do a bit more here, right? Now, obviously, when you're on your way up, the y values are negative underneath the x-axis. Then your y values end up being positive. Your graph is increasing. If you ever played the game Super Mario, the old school one, 2D, to complete the level, you run from the left to the right. You run from the left to the right. And if you're going up a hill, you're increasing. If you go down the hill, you're decreasing. Everybody got that? From left to right. So, you're on your way up, you're on your way down. Now, on the top of the hill is known as the local maximum. If you're asked for the local max, let's say for argument's sake it's minus 1.5 and 40. The local max is 40. Okay? So if I ask you a question, what's the local max? You just say 40. If I ask you for the maximum point, what's your answer? Minus 1.5, 40. Kill that. What's the local min, roughly? We'll just call it 25, let's say, minus 25. Are we cool with that? And then if we're asked for the actual point, it'll be something like 2.7 and minus 25. Is that okay? Now, alright. So, what are the roots of this then? Where does it cross the x-axis when you factorize it? You just put all this equal to 0 and you'd find out it's x equals 4, which is this one here. X equals, that's a plus 3. X equals minus 3, which will be over there. And then finally x equals 1, which will be there. Everybody happy that when you factorize, you can find out the 3 points of which it goes through there? Grab. Daily.
Why are you allowed to take out the 2 and then have it multiplying?
At the front?
Yeah, so that'll make 2x minus 2.
Yes, but, right. How to explain this? Right, 48. Right. I'm going to pick 3 numbers that multiply to give me 48, okay? I'll start off with 8 times 6. Is that okay with you? Then I'm going to take out 2 for the crack. 2 times 4 times 6 still equals 48, yeah? I can throw the 2 anywhere I want. I can pair it off with anything I want. I can do 2 times 6 to get me 12. And then 4 times 12 is 48. Or I can do 2 times 4 to get 8. Then 8 times 6 is 12. When it comes to multiplication, I can send that 2 anywhere I want. I can send it to the end as well. I could actually have a 2x minus 8 at the end if I really wanted. For example, you guys might factorize this, right? And you'll end up factorizing it 3 different ways, believe it or not. Somebody might get an answer of 2x minus 2, x plus 3, and x minus 4. That person put the 2 at the front. That's still a correct answer. So it doesn't matter where you put the 2. To avoid this confusion, always have it fully factorized. Take the 2 out. Is that right? Now, is everybody cool with that? We all good? Alright. Grand, next thing. 3 roots, 2 of which repeat. What happens this time? We factorize this, and then what happens? We get x plus 3, but we also get x minus 2 squared. So what does that mean? X equals minus 3 is a root, and then x equals 2 is a root. But it's a root twice, isn't it? Because it's x plus 3, x minus 2, and x minus 2. And there's your 3 roots there, isn't it? See the way it only touches? So it hits the graph, it hits the x-axis twice, not 3 times. Everybody cool with that? Once again, local max and local min. Alright, let's keep going. One real, two non-real. What does that mean? So, what happened was, we have this equation here, which is the equation of the curve that's drawn over here. Everybody cool with that? And we factorized it. When we factorized it, what happened was we got these two factors here. We got x minus 2, and then we got x squared plus 2x plus 2. The unfortunate thing is that we tried the minus b formula here. And what happened when we tried the minus b formula? We got mat error. And why did we get the mat error? We had to end up getting the square root of a negative number. This means that this quadratic equation yields no roots, which means there's only one real root then, isn't there? What's the real root? X equals 2, as shown on the graph. There's your real root, and the graph doesn't intercept anywhere else. Everybody cool with that? The local max is still here. That's still your local max, and here is still your local min. Alright, let's pause it there. So, what would have happened here, guys, is we would have done the minus b formula on this part here, see it? So we would have got a is 1, b is 2, c is 2, yeah? Then it'd be minus 2 plus or minus the square root of, 2 squared minus 2 squared minus 4 times 1 times 2. So square root of minus 4, is that right? Alright, now guess what and then 2 times 1 on the bottom. Now here's what they did. They did minus 2 plus or minus the square root of minus 4. Now here's what they did instead, right? Can anybody tell me, root minus 4 is the same thing as root 4 by root minus 1. You cool with that? Which is the same thing as 2 root minus 1. That's what they did. So then they did 2 root minus 1. I think what we're doing here is a waste of time, but anyways, we'll go through it. And then divided by 2, and what's your 2 roots? Minus 1 plus 2 root minus, minus 1. Divide them both by 2, isn't it? So it's minus 1 plus root minus 1, and the other one is minus 1, minus root minus 1. Now, what do we know about both of them? You can't do them, can you? They're both maths errors, aren't they? But get this, see the 2. You bring the 2 back over, that's one factor. And guess what they did? They brought the whole thing back over the other side to form the factor. So the factor would be x plus 1 minus root 1. It's needlessly complicated, I don't know why you do it. Is that alright? You get the gist. Minus b formula doesn't work, only one root. That's all you need to know. Okay? That's where they got that from. Alright, let's keep moving. 4. Now this one's an interesting one. What can you tell me about f of x compared to g of x? G of x is simply double f of x. That makes sense? It's doubling. So what does that mean? Whatever y value f of x has, g of x will have a y value twice as large. So, I wish there was actually good points here. There's not. No good points to really say. But look, if that was 0.35, that one would be 0.7. Does that make sense? Now, what you know is about where they intercept the graph? What you know is about where they intercept the graph? Exactly there, which is expected because if that equals 0 and you factorize out 2, what happens? You end up with the same equation, don't you? And you can just divide both sides by 2, and then you're just left with the same thing, aren't you? One of them is twice as big as the other one. That means I can make one that's 3 times bigger, and it'll just look like that, if you get what I'm saying. I can keep making them, and they'll keep intercepting at the same 3 points. Is that alright with you guys? Alright, awesome. Now, what happens when you multiply by minus 1? So, here's your original equation in yellow, which is this one here. And here's your other equation in blue. What did I do with the yellow equation to form the blue equation? I multiplied it by minus 1. And what happens when I multiply it by minus 1? Mirror image in the x-axis. Do you got that? It mirror images it. So it reflects it in the x-axis. So for example, if this was the point, I don't know, 0.4 and 0.45. What is it on this one? Still 0.4, but what's the opposite? It'd be negative 0.45. Does that make sense? Alright. Alright, pause it there. Have I lost anybody on the recorders? If for some reason you forget what's going on, set up a really simple U-shaped graph in your calculator. Like let's say just something really basic like x squared, let's say something really basic like x squared take away 3. And draw that from, I don't know, draw it from, let's say, minus 5 to plus 5, okay? You draw the graph. Then multiply it by 2. What happens if you multiply it by 2? 2x squared minus 6. Draw a quick sketch of that. And what you'll realize is that your new graph is twice as tall as your old graph, wouldn't you? And what happens if you multiply that graph by minus 1, where you now set up as minus 2x squared plus 6? What will you notice then? It just inverts it. The y values change from positive to negative. Also, that does is changes the y values from positive to negative. If I had a point 1, 5 in one graph, that'd be the point 1 minus 5 in the next graph. You get what I'm saying? Just changes the y values from positive to negative. Alright, let's keep going. Oh dear, look at this. All the graphs pass through 0, 0, but they, yeah. Alrighty, I'm going to take out my GeoGebra package for a second. And the first thing I'm going to draw is, we're going to draw the function y equals x cubed. Y equals x to the power of 3. Everybody cool with that? Now, see the way it bends? See the way it goes through the middle and then back up again? Now, if we were doing that in our calculator, y equals x cubed, let's say from minus 5 to plus 5, you can see it's all the way down at 3 minus 27. 3 minus 27 is, nope, that's not it. This is it. Function. There you go. So, 3 minus 27 is around there. We got that. But on the opposite side, you're going to have 3 plus 27. You get what I'm saying? So it's quite the unusual graph. Now that's just y equals x cubed. Can anybody tell me what happens if I do y equals 2x cubed, let's say? Y equals 2x cubed. What are you expecting to happen? Make a prediction. The y values will be doubled. In both directions. They get doubled going up and going down. Look what happens. This one here is roughly that's at 8, isn't it? And where's this one at? 16. Do you get what I'm saying? It doubles it in this direction and it doubles it down here as well. Now, can anybody tell me, make a prediction? What happens if I do y equals minus 2x cubed? Let's find out. It's reflected in the x-axis, but it also looks like it's reflected in the y-axis as well. Would you agree with that? It's mirror image in the x and in the y. The red one got reflected onto the blue one. Is everybody cool with that? So the red one got reflected onto the blue one. You cool? So I'm going to pause it there. Is there anything you want to question me about? Come. Alright, where's my undo button? Alright, I'm going to go back to the original. What was the original? Can anybody remember? Y equals x cubed. Can anybody tell me what happens if we do y equals a half x cubed? Come on. Find 5x cubed. Goes wider, doesn't it? Can anybody explain why? I'm halving my y value. So what was 8 is now 4, isn't it? 2, 4 compared to 2, 8. So I'm halving it. So in a way it makes it shallower. Do you get that? So this whole slide was about making it shallower and steeper. You got the gist? Hopefully. One can. Now, just a summary. Every cubic polynomial crosses the x-axis at least once. Each root produces a factor of the polynomial. Example, x equals minus 3 means x plus 3 will divide into it. If a polynomial has a repeated root with an even power, something like this, then the graph touches but does not cross the x-axis at these points. You know what I'm saying? If you have x plus 3 and x minus 2 squared, what does that mean? Crosses it at minus 3, but doesn't cross it at x equals 2. Alrighty. If the coefficient of x cubed is positive, the graph starts below the x-axis. So, let me give you an example. Once again, like Super Mario. Okay? You're going left to right, aren't you? If it starts off with, let's say, x cubed plus 5x squared minus 2x minus 7, something like that. If it has a positive x cubed value, what does that mean? Mario starts down here, and he goes up, down, and then back up again. Everybody cool with that? What happens if it's negative? As in minus x cubed minus 5x squared. I'll just do the complete negative here. What happens there? Yeah, it's a mirror image, but the main thing is if it's a minus x cubed, you start above the x-axis. You hit your minimum first and your maximum second. Does that make sense? So what you could write here is max first, min second, yeah? And here it's min first, max second. When moving left to right. Okay. Some cubic graphs have local maximum and local minimum turning points. The ones we did earlier, do they have a maximum and a minimum? Let's find out. Right, gonna drag it all the way down. I'm gonna bring it. I'm gonna do it the other way. Oh no, the other way, sorry. Oh god, they don't. There's no turning points there, is there? Doesn't exist. So for that graph, there's no turning point. You get what I'm saying? Alright. Well, do you notice they're always increasing as well? These x cubed graphs on their own. You're always running up a hill, aren't you? You never go downhill, do you? Some graphs are like that. Maximum minimums mean you're increasing, then you're decreasing, but in this case you're always running up the hill, which means you're always increasing. Okay, covered a lot of points there. When forming a polynomial from its roots, check for an integer factor. What do we mean by an integer factor? Say, for example, imagine I said the roots are x equals 4, x equals 3, and x equals 2. What could you say the factors are? Yeah. And you would multiply them together to get the formula, wouldn't you? But what's the issue? Any number on the outside, any number at all, they also cross those 3 points as well. So you have to make sure it fits the graph. So you might end up with an equation, and you look and go, my equation's too short. It should be double that height. In that case, you would lob a 2 in front, and you'd multiply it out. Okay, you'll see later on. All right. I'm gonna make us look at these questions, examples, because they're good to use at the start, alright? Find the expression for this cubic polynomial. No bother. What's the maximum point? -1. Minimum point? Minimum point is 1, 0. Alright, and can anybody tell me the roots? X equals? And x equals? How many times? Twice. Why is it twice? Exactly, alright? Now, here's the issue next, alright? What I'm going to argue is this. I'm going to say, alright, no bother. This means f of x equals, use the factor term. It's going to be x plus 2, isn't it? It's going to be x take away 1 and then another x take away 1. However, I have to be aware of one thing, don't I? What do I have to be aware of? It could be 2 times that. It could be 3 times that. I don't know how many times I need to multiply it by. So in this case, I'm just going to write down the letter A. Go with this? Pick any point on your graph. Let's pick the max. So what does the max say? -1 and 8. Pick something that has a y value. Do you get what I'm saying? Pick something that has a y value. So y has to equal 8 when x equals -1. Agreed? Let's check it out. Let's go down here. Y equals 8 when x equals -1. Replace in -1 and what do we get? What's -1 plus 2? 1. What's -1 minus 1?
0.
-2. What's -1 minus another -1? What happens when you multiply all this out? You get 4a. 4a equals 8. A therefore must be 2. Therefore our function is 2 times x plus 2, x minus 1, x minus 1, which can also be written as 2 times x plus 2, x minus 1 squared. Go with that? Alright, I need to find you a question exactly like that to try out yourselves. Yes? What? It's a repeated root daily. Hits it, it doesn't pass through it. So it means there's 2 of them. Okay? Alright, let's find you guys a question. Leave that one alone for a minute. Alrighty. Yeah, can I ask you to do question 1 part 2 please? Question 1 part 2. The first thing I'm looking at is I'm looking for the 3 points which it hits the axis. So I see x equals -4, which means x plus 4. I see x equals 1, which means x minus 1 is a factor. And then I see x equals 2, which means x minus 2 is also a factor. Then I say, alright, no bother, this means my function, f of x, must be, it's definitely x plus 4, x minus 1, by x minus 2. However, I'm not guaranteed that, am I? Because there could be an a factor in front. Test any points that has a y value. What point will have a y value? 0, 8 looks pretty handy, doesn't it? So what do? Replace f of x with 8 and replace all the x's with. So again, I'll end up with 4, minus 1, and minus 2. Is that alright? Yes? See the point 0, 8? This means when the x value is 0, the y value is 8. Anywhere I saw an x, I replaced it with 0, and then I replace fx with 8. 4 times minus 1 times minus 2? 8a. So what does that mean about the formula? 8a equals 8, which means a equals 1. Am I entitled to full marks? Why am I not entitled to full marks? Why do I have to multiply it out? It says it wants it in the form ax cubed plus bx squared plus cx plus d. Basically it says it wants it like this, which means I'm going to have to multiply this out now. So you gotta multiply it out to get full marks. Go. So I'll multiply these two first. I'll get x squared minus 3x plus 2. And then I'll multiply by the x plus 4. And I'll get x cubed minus 3x squared plus 2x plus 4x squared minus 12x plus 8. I will then arrange this in order of size, and I will get this. Who got that? Right. Done.
When you get your A's,
The A value just comes in here, in at the front. But because it's 1, I don't have to do anything with it. If it was 2, I'd multiply then.
Oh.
Or I'd multiply all this answer by 2. Whatever you need to do. Okay. Alright, we're done question 1. Alright, chill out for a sec. What does this want? Well, write the polynomial expression for each of the following cubic graphs. Alright, no, we won't. Wait a minute. Alrighty. Here's what I want from you. I want us to do the red and blue of part 2. I want these two graphs here. Okay? Just these two graphs here. Does it say we have to multiply it out? Doesn't, does it? If it doesn't say it, don't do it. No need. Leave them in the factors. I suppose it was in an exam. I'd do both. Yeah, you're right. Both graphs have a lot in common. I think one graph is twice the other graph. Would you agree with that? 0, 12 and 0, 6 indicates there's an A value 2 at play, or something like that. I would then say x equals 1, which implies x minus 1. X equals 2, which implies x minus 2. And x equals 3, which implies x minus 3. I then make up the following equation with the A value, x minus 1, x minus 2, and x minus 3. I then test out the point 0, 6. I put 6 in for y. Then we get A and 0, 6. So that means the x value is 0. So 0 take away 1, 0 take away 2, 0 take away the 3. I'm going to get minus 6a. Does that make sense to you guys? And the a value is actually minus 1. How did I know that was the case? Because Super Mario started above the x-axis, not below the x-axis. So I knew that was the case. So, the first can anybody predict what the next one's going to be? It's going to be an a vector of, because you know it's 0, 12, yes? Yeah, I'd say so. In that case, yes. Alright, so the two equations then, you can multiply it out if you want. I just think, in a test, guys, what would you do? If you weren't sure, you'd multiply it out. So the two answers we're going to have are this. Minus 1 times. And once again, if this is the leaving cert, I invest the time in multiplying it out. And then finally, what's the second answer then? Sorry, what's the second answer? Minus 2 into. That cool with you guys? I'm expecting you to be able to multiply that out. Okay? Move on. If you want, you can do 1 times that, get the answer. Multiply the two of them by each other. And then whatever the answer is of the first part, multiply by the answer of the second part. And you can do it that way if you want. We're not going to invest the time doing that right now though. Okay? Alright guys. Alright, too easy. Alright, question 5, have a look. Here's what I do in your case. I find out which graph is which first. Now, would everybody agree that the green graph has to be x cubed plus 2? Why? If you replace x with 0, what's the y value? Alright, so we verified that's the green graph. Okay? Which two are crossing? The green and the red, isn't it? So we know that's the green graph. Now, the red graph is steeper than the blue graph. So which one do you think it is? 2x cubed will be steeper. So the red graph is 2x cubed. Now what can you do with both answers then? They equal each other, don't they? Because when you intercept each other, you have the same x value and you have the same y value. So x cubed plus 2 equals 2x cubed. 2 equals x cubed. Alright. What's the cube root of 2? What number, when you multiply it by itself 3 times, gives you 2? 1.26, call it? Does it look like 1.26? Find out. Only when the graph verifies your answer. It's roughly halfway between 1 and 1.5. So I'd be pretty happy with that answer. However, I'm not allowed just the x answer. What else do I need to find? The y answer. Which formula do I need to use? I have a choice, don't I? Both points are on both graphs, so I can either use the yellow option or I can use the green option. And both answers will turn out the same. I'm pretty sure we can see the answer, can't we? 4, isn't it? But if you didn't have the answer, here's what you'd do. You'd say y equals 2 times x cubed, and we know what x cubed is, don't we? 2. 2 times 2? 4. This makes this point 1.26 and 4. We good? Okay. Yes? Anytime, ever since second year, anytime you have two graphs. So let's say, for example, y equals 2x minus 1. That's a straight line that crosses the axis of minus 1. And then I say, oh, there's another line, y equals minus 3x plus 2. That's a negative slope that crosses at plus 2. And see the way both of them intercept each other? What I can just say is, let y equal y. And it's another way of doing a simultaneous equation. I can find out the x values then and the y values then. Right? It's the same principle. Okay? So that's 1, 2, and 5. Alrighty. Let's draw a rough sketch of the curve. That's a bit too easy. Question 8. Alright. So x bar means you have x equals minus 1, which will imply x plus 1. X equals 1, which means x minus 1 is a factor. 2 hits twice. See the way it touches it and comes back? So you're going to have x equals 2 twice. Makes 2, yes? What you mean? See the way it comes up and then comes back down again? See, it touches the axis and comes back down again. Oh, yeah. Well, it goes straight through 1 and minus 1. There's no turning involved there. It's when you go to the line and you barely touch it and then you come back again. Okay, that's how you know it repeats. Okay. So, we found all the factors. Now we're going to have to find A, B, C, D, and E. Well, that's not going to be too bad. So here's what we're going to do. We're going to do x plus 1 by x minus 1. We're going to do x minus 2 and x minus 2. Please don't remember your A value. You might need it. test the point 0, test the point 0, 4, won't it? As long as when you put in 0, x equals 0, y equals 4. I think the a value is going to be 1. So that'll be 1 minus 1 minus 2 minus 2. Yeah, it's going to be minus 4a. Minus 4a equals minus 4, or equals 4. A equals minus 1. Yes? That's for an x cubed graph. This is an x4 graph. Remember we said Mario starts underneath the axis, it's positive. That's only for an x3 graph, not an x4. This is an x4 graph, okay? So, it's minus 1 times x plus 1 by x minus 1. And then it's going to be x minus 2 by x minus 2. Alright, I'm going to pair them off and multiply them. I'm going to pair the two of these off. And I'm going to pair the two of these off. So, when I multiply this out, I'm going to get x squared, difference of two squares is x squared minus 1. Perfect square is going to be x squared minus 4x plus 4. Color code them so you know where it went. This one's the yellow one. This one's the green one. Now I'm going to multiply the two of them by each other. And 2 in the first one, 3 in the second one. This implies I should have 6 items in the next part. x4, 4x3, 4x squared, minus 1x squared, plus 4x, minus 4. Keep going. Still not done yet. This is awful. x4. Yeah. Minus 4x3 plus 3x2. Take away 4. Multiply them by minus 1. Minus x4 plus 4x3 minus 3x squared plus 4. That's my answer. Where? 4x. Oh, where's the 4x? Ah. That part there, yeah? Multiply it by minus 1, you get minus 4x and plus 4. Alright. A equals minus 1, B equals 4, C equals minus 3, D equals minus 4, and E equals 4. Right, and what questions have I done so far? 1, 2, 5, and 8, was it? Right, thanks. This is what we learned earlier. Look at this, okay? Lads, you looking? Alright. First of all, f of x is the original. Oh, sorry, and g of x. What you know is about f of x and g of x? They're almost like a mirror image of each other, but there's a problem with them. They're not perfect mirror images of each other. What's the issue? F of x is twice as large. So for me, I would say that the a value, actually, you have to make f of x shorter, don't you? You have to half its height and change its direction. So how'd you do that? How'd you half its height? If you have f of x, oh sorry, I'm wrong. It's g of x we're affecting. We're going to multiply g of x by something. G of x, 0 minus 2 and 0, 4. What does that tell you about f of x compared to g of x? It's twice as large. 2 would go well. But what else can we say? Why is it a minus? Because it's a mirror image. Would that be alright? So it'd be minus 2 g of x. Is that right? You could write that down. It's a mirror image and twice as long. Now, either way, I have to find the equations, don't I? So it doesn't make a difference. I could use part 2 to answer part 1. Does that make sense? As much as concentrating on this. I can use part 2 to answer part 1. So here's what we're going to do. Alright, what's the intercepts? X equals minus 2. How many times? Twice. X equals 1. How many times? Twice. So, f of x therefore is going to equal x plus 2, x plus 2, x minus 1 and x minus 1, and don't forget about my a value. Yes?
You say x plus
You could. Yeah, you can do that as well. Alright. The point 0.04, lads. Would you also agree this also works for g of x? Why does it also work for g of x? G of x has the same roots. Would you agree with that? Okay. Here. I'm just being lazy there. There we go. And I'm just going to change that to g of x and go. And then g of x therefore will also be a times x minus 2 squared, x minus 1 squared. Right, so far so good. Now, what can we say about, give me a point on f of x. What point do we have on f of x? 0.4 sounds great. So what are we going to do here? 4 equals a times minus 2 squared, and I'm replacing all the x's with zeros and the y value with 4. And what am I going to get? 4a, a equals 1. Is that okay? So therefore f of x will equal, the formula for f of x, just get rid of that. Just get rid of the a value, won't you? So is everybody happy with my solution for f of x? Which is, my solution for f of x is what's in green. I just got rid of the a, because a equals 1. What about g of x? What points on g of x? 0 minus 2. Put a minus 2 here, and then replace the a value with 0. And you're going to get 4a equals minus 2. And what does that say about a? Minus a half. Okay. Therefore, what's the formula for g of x? Minus a half, x minus 2 squared, x minus 1 squared. And that's the formula for g of x done. Does it say I have to multiply it out anywhere? Nope. Doesn't say it. I'm not going to do it. We good? Once again, if it's an exam and I had time, at the end of exam, I might go back and multiply it out. Right? But I wouldn't do it now. I'd finish off the rest of the leaving certs. Then if I had a couple minutes to kill at the end, I then might do it. It doesn't tell me to do it, does it? So then, there's not really, shouldn't really invest the time unless it tells you. Okay, let's move on. Yes, Carl? Yes, you can. Oh, that's too easy. Actually, maybe not. Try that one. See the a value in part 1? Yeah? The a value in part 1 and part 2 are actually different. Okay? But what we did learn is that g of x is only half the size of f of x. So that means 2 times g of x would be the same height as f of x. But, it's also mirror imaged as well. So it'll be minus 2. So a would be minus 2 in question 1. But in question 2, your a values are different. They have nothing to do with it. Is that okay? Alright, it's a good question. Alright, lads. Did anybody get x plus 2 for the first factor? The second factor is slightly trickier. Multiply it by 4 to get 4x equals 1. Then you're going to get 4x minus 1. Is that okay with you guys? And then x equals 3, so it's going to be x minus 3. Do I have to multiply them out this time? Why? Yeah.
Do you not say x is minus 4? Or your x or
Do you really want to deal with? Do you really want to deal with fact? With
no, like
fractions?
if you did it.
Yeah, I'm actually going to explain that answer in a second. It would work. Just give me a second at the end to explain it, but you're right, it would work. Okay. Now, so multiply it out. I always go for the second two first. Don't know why. Then x plus 2 here. Multiply it out, second 6 parts. Or x cubed minus 13x squared increase 3x plus 8x squared minus 26x plus 6. Now what do we get here? 4x cubed minus 5 x squared minus 23x plus 6 equals 0. Did anybody get that? Alright, I have a question for you. If I multiply this by any number of my choosing, is the answer still valid? What's to say specifically? A cubic equation with the following roots. So imagine for argument's sake, you're just after doing this one here. And what are the roots again? Minus 2, a quarter, and 3. Minus 2, there's a quarter, there's 3, for argument's sake. Okay? 3, a quarter, minus 2, not drawing this yet. Alright? What happens if I multiply this by 2? And I gave you this as my answer instead. Oh, sorry. If I multiplied this by 2 and gave you an answer like this instead, does it still qualify according to the question? Why does it still qualify? It didn't specify. It just says you need those 3 roots. Well, there's 3 roots right there. If I multiply by minus 1, will it still work? It will. It'll just be upside down, but it'll still say have the exact same 3 roots. Connell was actually toying with the idea of using remember he has x equals a quarter up here? Connell was toying with the idea of using x minus a quarter. Now, it's a lot of work. It's not a nice way to finish it, but this is what he would have ended up with. If I divide across by 4, Connell would have got this answer instead. Connell would have got x cubed minus 5 over 4 x squared minus 23 over 4x 6 over 4, which is 3 over 2. Connell would have wrote down that answer. And once again, he would have got full marks. Connell's answer would be 1/4 the height of this, so Connell's answer would look something like this. Do you get what I'm saying? I don't know why you'd want to do that to yourself, but it works. Is that okay? We good? Alright, let's keep moving on. Onwards and upwards. We are now going towards 13. Oh, it looks like a fun one. Alrighty. Where does f of x equal 0? Where does the green line cross the x-axis? Minus 1, 0, and 2. So x equals minus 1, x equals 0, x equals 2. Where does the y value for the curve equal the y value of the line? Where does the curve equal the line? this red dot here, and this red dot here. So I'd say x equals 0, and then the other one. What do we reckon? 2 points. Just the x value, isn't it? 2.3, 2.25, something like that. Don't worry too much, because we're about to find the answer normally anyway. Now, it's what we said earlier. The two y values are the same, which means the g of x must equal the f of x. Or you could say the f of x equals the g of x. What's the f of x equation? Lads, what's the f of x equation? X is not x cubed? Yeah. Yeah. And what's the g of x one? Get this, guys. It's going to be an easy one. We needed an easy win, and we're about to get it. Ready? Minus x squared, and then bring that over, and you get? Okay. Take out. And what do we get? Is that okay? We get x equals 0. We expected to get that, didn't we? Because we can see where the line hits the... Oh! I also forgot the third answer, didn't I? There's a third answer as well. Look at that one. How much do you think that is? 1.3, 1.2? Okay. Now guess what we're going to do? We're going to solve this minus b formula. And we're going to find out what the other two values are really easily. We're going to get a equals 1, b equals minus 1, minus b equals plus 1, c equals minus 3. We're going to go for 1 plus or minus. Somebody do this for me. 1 squared minus 4 times 1 times minus 3 all over 2 times 1. I'm hoping I get an answer roughly of minus 1.3 and 2.3. Let's find out. Come on, come on, come on. In decimal. Ah, 2.3. The other one. Champion. Alright. For homework. Hooray! The best part. You get to do them all weekend. Now, you're doing the red ones. Questions 3, 6. Oh no, you don't. 7, 11, 12, and 14.